Good morning. Let's try again. Good morning. All right, so first of all, I'd like to thank the folks at Akendi, Cap Chi, and Design First for giving us the opportunity to come here and share our point of view on the Internet of Things. It is truly an honor. This is a great room, and I think it's representative of what's going on in the industry in that we see a mix of makers, the maker community, startups, there's big company presence. So this is really what it's all about from an IoT perspective. Thanks for the opportunity. I don't know who wrote my introduction, but it's probably the nicest introduction I will ever get. So thank you for that. Do I have a clicker? So we are Wind River, and not to be confused with the Mark Warehouse clothing line. We are Wind River, the device software company. We do things like build reliable software that powers things like the Mars rover. We are an Intel company, and we are based here, or I am based here in Ottawa, and I'm pleased to be joined here with a few of my colleagues from the Ottawa lab. We have about 200 folks in Ottawa, and we actually have a group of people in Ottawa who are focused on building solutions for connectivity and manageability for the Internet of Things. And our development manager, Manish, who's in the back here, has asked me to advise you guys that we're actually hiring. So if this goes well, hopefully you'll come and see me and Manish afterwards. We talked about my role. I'm actually really excited about my role. I'm a bit of a gadget junkie. I've been a gadget junkie for a while. I think that's actually helped to foster my friendship with Dom over here. And my role at Wind River is really to manage our partners. So if we take a look at end-to-end IoT solutions, we've really seen that there's no one company that can provide an end-to-end solution. It really takes an ecosystem. As you look at taking the information off the device, adapting protocols, doing analytics in the cloud, or even stitching together or designing the user experiences around this, it takes an ecosystem. So I'm personally excited about this because my job life and my work life, my personal life, are now intersecting. I put this picture together for this presentation. This picture drives my wife nuts. But in summary, this is just a subset of some of the smart connected gadgets that I've added to our home in the last, let's say, 15 to 18 months. And it got started off with some devices that I use when I'm working out. So when I'm cycling or running, I like to get stats about how I'm getting slower as I get older and things like that. But the pivotal one was the one on the top left. So just by a show of hands, who has a Nest? Okay, not bad. Actually, the real question I should have asked first is, who has one of those Honeywell Peak Saver thermostats that Hydro Ottawa gave you for free? All right. In a box, yeah. Yeah, and if you went like a little bit further, you probably also got a little white thing there that's supposed to give you some data on how your time of day usage is. Anyhow, I had those devices in my home, and with no disrespect to Honeywell, they were terrible. They were ugly, they were big, they looked dated. They never worked. I would travel. It didn't know if I was home, if I was away. So one day I just decided to rip it out of the wall, and I bought the Nest. And the Nest has been fantastic. It did everything it said it would do. It learned, it knows when I'm away, it automatically cools, it sends me beautiful reports telling me how things are going. So I got hooked. And then I went down the garden path, and I went from a Nest, and I got the Protect, and I said, hey, I should get one of these smart scales. And before you know it, my wife's at the point saying she doesn't know how to operate our home anymore. But that's okay. That's just my personal story. But it's one of the reasons why I feel really excited about the potential of IoT. Let's get started with a definition. So I looked around, what is the Internet of Things? And first of all, it's a very catchy phrase. But if you take a look at the definition, in essence, it's really simple. It means that a device has an IP address, and it can talk to other things with IP addresses. And while that definition is very factual, it really does not give you a sense of the opportunity, or what I like to think of as the phenomena that is the Internet of Things. I really believe that the real value of the Internet of Things comes from the intelligent devices. And more importantly, what is an intelligent device? Well, I think an intelligence of a device will be determined by how we interact, or the nature of how we interact with the device. I don't know if you've seen this article. Just a show of hands, who has read Michael Porter's work on Right, so since many of you have not, I actually encourage you to do it. This is probably one of the best papers on the impact of smart connected devices to our economy and, more importantly, competition. And if you break down what Michael Porter's trying to say, and just for those of you who don't know Michael Porter, he is, I believe, a professor at Harvard. He's the creator of the 5 forces that drive competition. And he's also worked with one of our partners, a company called PTC, and the CEO of PTC, a guy called Jim Heppelman, to develop this thesis. And ultimately what they're saying is that the Internet of Things is going to enable the third wave of IT-enabled competition. And what was the first and second wave? So the first wave was simple. It's when we started using computer systems to automate tasks that we were doing manually or verbally, right? So accounting systems and things like that. Some of those were online. The second wave was really all about the internet economy, the emergence of Amazon, the emergence of Google. And what Porter is saying is that IoT is going to enable this third wave where we're going to have smart-enabled or smart intelligent devices that are going to introduce a new form of competition or enable companies to differentiate their offerings in ways they couldn't do before. Or said differently, the Internet of Things is going to help transform the value chain. And what I find particularly interesting about this thesis is once you start looking at it from not just the perspective of the device, but you start thinking of the data coming off of the device, and more importantly, how that data is consumed as part of the overall end-to-end value chain, you start to find these really, really neat opportunities, right? Where in many cases, the person who makes the device or operates the device is not the person who's going to get the most value or benefit from the device. And I think the most common example that we've all seen of this is the insurance companies. So insurance companies don't make devices, they sell insurance, automobile insurance. But what they're able to do right now is working with the makers of these devices, they're able to get telemetry information from the device to understand how you're driving your car and to tailor insurance packages for you. So this is an example of the type of transformation that these smart connected devices can enable. So there's a lot of buzz. We're all here today. The Internet of Things feels new. Some people think it's hype. It's not. It's reality. Folks will argue that, and I think it was Leo who said it in the first talk, companies have been doing the Internet of Things for years. They just haven't called it that. We think that the future is now. What's changed, well, if you take a look at what folks are doing right now, is you have a lot of what we like to describe as stovepipe implementations. So if you look at some of the energy utility companies, or you look at companies like BMW, they've all got smart connected infrastructure which is enabling them to optimize their businesses. One example that I reflect back on, I think it was about 8 years ago, we were talking to a company that was making devices to instrument cows, or you could think of it as smart connected cows. And we looked at this and said, okay, well that's kind of neat. Why does the cow need to talk to the internet? And, but really the business problem that they were trying to solve is they were targeting farmers in places like New Zealand or Australia where they have huge amounts of land. And the challenge that they've got is just managing their herd or tracking their herd was an extremely costly process. And because their land was so big, the cows drift and sometimes the cows get stolen and stuff like that. They had a hard time tracking them. So they tried collars and things like that to track the cows, but they would gnaw them off. And ultimately, the solution they went for was an RFID solution, where they would use very low-cost sensors, tag the cow's ears, and then use satellite coverage in order to monitor them, get analytics to see how the cows were migrating and moving around, and use that to optimize their herding things. So these are examples of things that people have been doing for years. What's changed? Well, the conditions have never been better. So if you take a look at the cost of bandwidth, how do I connect these devices? The cost of bandwidth has dropped 40 times, or 40x in the last 10 years. Sensors, I think earlier today, Adam was talking about an exercise we did yesterday where we were attaching sensors to plants. Think of it, 10 years ago, who would think about the business model of you couldn't afford to put a sensor on a plant. Now you can. And then the cost of compute, right? So compute on the device as well as compute in the cloud, that has gone way down. But this slide doesn't tell the entire picture. I think there's other dynamics that have made the conditions very favorable. Specifically, if you look at things like continuous engineering practices or continuous delivery, DevOps, all of this makes it easier for people like Leo and his son to just basically get a board, connect it up to the cloud, and then start coding and doing things in order to experiment and get business value. So, the conditions are perfect right now. We think, so this is my number slide, and we see the opportunities being very big. So we estimate that by 2020, and when I say we, I'm referring to Intel and Wind River, we estimate that by 2020, there'll be at least 50 billion smart connected devices. That's about 7 or 8 for every man or person on the planet. We estimate that from an economic impact, and this might be conservative, we've seen numbers as high as 20 trillion, but we estimate there'll be a $15 trillion impact to the economy in terms of either money saved or revenue generated as a result of Internet of Things opportunities. And it's a growing market. But the most exciting thing about all of this is that it's a market opportunity that's available to everybody, right? And one of the exciting things about my job is that I'm not only talking to big companies who have ideas on how to make money from the Internet of Things, we're talking to a lot of startups. And while they don't have enough money or capital to buy our products, typically they have fascinating business models where we could look at the value chain and we could say, hey, listen, yeah, we see how you can monetize this in the back end. Let's work together to figure out how we could get our technology working with your solution, and we can all make money. So it's a really, really big opportunity for all of us. There's 2 flavors of IoT. Very simply speaking, we see that there's this notion of consumer IoT, so things like your Fitbit or your smart home. And that's a good opportunity, it's an important opportunity, but if we take a look at the overall opportunity, we estimate that that might be maybe between 10 and 15% of the overall IoT opportunity. Where we see a lot of the money aggregating is around what we call industrial IoT. And what do I mean by industrial IoT? Well, industrial IoT is things like smart manufacturing, transportation, connected vehicles. The speaker before me, wonderful talk by the way, talked about health, smart connected health. This is a huge opportunity for us, and she's absolutely right in that, due to many concerns, some of them regulatory, some of them privacy, we haven't really tapped into that opportunity yet. So these are the 2 different flavors that we look at. Now, there's a lot of differences between them, right? So in a lot of the consumer-based IoT things, you're really having the interface that's talking to you or to your smartphone. As we look at the industrial type use cases, they tend to be a little bit different. A lot of it is machine to machine or machine to infrastructure enabling B2B type operations. But that said, there's a tremendous amount of similarity between them as you start looking at concerns of ease of use, ease of deployment. Kendi probably dealt with that when they were building the ecobee thermostats. All of these things are similar concerns that basically transcend both of the consumer as well as the industrial space. In terms of business interests, we like to keep this simple. So we believe that there are, while there's 2 kinds of, or 2 families of IoT applications, I think there's 2 characteristics of IoT ideas. And that's the ones that are going to make money or the ones that might never make money. And in terms of making money, we feel that companies who are looking to use the data off of these devices to optimize their operations or do some level of business optimization or generate some efficiency, positive shifts in OpEx and CapEx, that's one category. The other big category is folks who want to use the data off of these smart connected devices or the insights that these devices are giving us as a way of creating new revenue streams, delivering new value to either existing or new clients, value capture. So I'd like to talk to you about an example. This example comes from one of our customers. It's a customer called Daikin Applied, and just who has heard of Daikin? Okay, so not too many of you in the room. So Daikin is in the business of doing HVAC, or heating, ventilation, and air conditioning systems. They're rooftop air conditioning systems. They've been in business for a long time, and I think their run rate's probably on the order of about $17 billion. So they're doing really well. A couple of years ago, Daikin said, as well as we're doing, we need to do better. As we take a look at things like customer satisfaction, our operating costs, or generating additional revenue from existing customers, what can we do differently? And then they started on this mission of what they call intelligent HVAC. And they had 2 use cases, and these use cases map to my business optimization and business transformation slide before. So the first one was predictive maintenance. And I'm going to just, make just to turn up the contrast a bit, I'm going to make some broad generalizations. But if you take a look at the state of art for HVAC operations and management, it's pretty simple. You install the HVAC on top of your roof, and for the most part, you typically call the maintenance people when in the winter it's cold because the HVAC system's not working, or in the summer the building is incredibly or insufferably hot, right, because it's not cooling properly. And if you sort of follow through the logic of everything that's happening here, this is actually a tremendously costly issue, right? What will happen with Daikin is, first of all, they have to get a technician out to the building to figure out what went wrong. Once they get there and they identify and troubleshoot the problem, this could take time. They might or might not have the parts on their truck in order to fix the problem. Again, show of hands, this is real. Who has had an air conditioner or heater break down, had a technician come by only to find out that they couldn't do anything for you because they had no idea? A real problem, right? You're not happy as a customer when that happens because your house is either still cold or too hot, and you're upset. So what Daikin was able to do is they were able to attach what we call a gateway. So if you take a look at it, Daikin had several HVAC systems deployed worldwide. To replace them all was cost prohibitive. So what they wanted to do was take the unconnected and connected. So they took these Intel gateways running our software, Wind River software, and they were able to build some intelligence on top of that in order to monitor units, in order to predictively maintain. They could now get analytics or information saying that, hey, listen, based on some of the vibration information we're seeing on some of these sensors, this unit is likely going to fail early. We could actually dispatch a maintenance technician with a piece to repair that ahead of time. So that's, the example of what they're able to do with some of this diagnostic information. But they didn't stop there. They said, well, we could take the information that we know about what's going on in the building and we could combine it with information that we know that what's happening with the weather. And now we could start offering our customers, well, they're charging for these services, but new services to do things like, well, hey, listen, if we know it's going to be a really hot day tomorrow, what we will do is we will pre-cool the building at night while energy prices are lower such that it'll be comfortable throughout the day, right? Or vice versa. If they know there's a storm coming on, we know that we don't have to use as much cooling efforts because the environment's naturally going to cool it. So these are examples, again, of people using the data coming off of these smart devices in order to influence outcomes and generate some new business value. At Wind River, we believe that there's 5 essential tenets to successful end-to-end IoT applications. The first one, there has to be a monetization model. Like, you absolutely have to understand the value chain and who's going to pay for the devices and who's going to pay for the services. Actionable analytics, right? And I'll talk about this later in my talk. But more often than not, we see a lot of companies who are focused on getting data off of their devices into the cloud, but then they don't know what to do with the data, right? And I think in many ways, the second tenet is related to the first one, in that they haven't really done all the thinking around the value model. Data normalization. I was out last week or 2 weeks ago in Redmond, and we were talking about one of our partners who does storage. You probably have guessed who they are by now. And one of the problems that they were looking at was the airlines. So if who could just guess how much data is collected by an airplane? Let's say a 6-hour flight. How much data is collected by that plane? Just throw out a number. Just yell it out. Don't. A terabyte? That's not bad. 6. You're showing your age. 600 gigabytes on average. That's a lot of data, right? And a lot of it for most successful flights is, I'm okay, I'm okay, I'm okay, I'm okay, right? So, which is a good thing, right? But the challenge here is, what do you do? How much of that is useful, right? So when you get that, when that plane comes into the hangar, do you upload it to the cloud? How do you upload it to the cloud? How do you decide what subset? So as you think of end-to-end solutions, these are some of the things you need to think about as you're factoring the business model. Discovery and provisioning. What happens when a device comes to the network? Is it allowed to participate in that network? And then safety and security. And I'll pause here for a bit because I believe that safety and security could potentially make or break the adoption of IoT in the near future. Right? I think that fundamentally, if we start going off and buying devices and we find out they're not safe or reliable, it's going to slow the market down. Let me talk a little bit about what I mean by safety and security. So if we think of the system, right, the system being some combination of devices that are smart and connected, Safety, from our perspective, is making sure that the behavior of that system doesn't negatively impact the environment. So again, just to draw some contrast, what you don't want to have happen is an IoT-enabled nuclear reactor blowing up, okay? Security is almost the exact opposite. So you've got your system, you want to ensure that the environment doesn't negatively impact the system. And by environment, we mean the hackers. And then there's another element which we should probably add to these charts, and that's what I like to think of appropriate amount of privacy. And this is a huge concern, particularly in the healthcare industry, where lots of folks are worried about their patient care or patient data because it impacts things like insurance rates. But on the other side, having that data easily available enables other people to do analytics and run patterns in order to do better healthcare. So privacy is another, or the appropriate amount of privacy is another key concern. I hope most of you have heard of this story, but this is what happens when a hacker meets a smart connected vehicle. The guy on the left is a guy named Chris Valasek. He's actually a really nice guy. He's got this scowly face, which is all for marketing purposes, but he's a really nice guy. And his day job is that he's a researcher. His job is to look at these IoT systems, particularly the transportation systems, and identify, areas where they're vulnerable and, how you could better develop safe practices to protect against them. The thing on the right is the Chrysler vehicle that they hacked. And so who has not heard about this story? Because I want to be respectful of your time. Okay, a few of you. So it's worth discussing. I'll keep it brief. But in summary, what they did is they went through I believe it was the AT&T network. They found a connection to this particular car. They tunneled into the car's IVI system. And they started off, first of all, by changing the radio stations. Then they started, this is true. Right? Then they moved on from there to turn on the air conditioning full blast. Then they started operating the wipers. And those of you who know how a car is built, all of these systems are connected on the CAN bus, including the drive-by-wire systems. And then I think they hijacked the brakes and then the steering. And here's the car in the ditch. And this is basically what we describe as the automaker's nightmare. Right? Now, Chrysler, to their credit, responded as well as they could. But I think as we dissect as an industry, as we take a look at what happened here, it's becoming increasingly important that we identify a set of best practices around how you secure a device. I think Chrysler's number one learning from this is that it's important you have the ability to update software remotely, right? So they had millions of cars that they had to refresh, and I will say that while they handled the initial PR, they did not handle the upgrade process really well. One of the jokes that I heard at dinner last week was a wife of one of my colleagues heard about this, and she says, well, Chrysler seems to be having such a hard time updating the cars. Why don't they ask the hackers to do it for them? Yeah, I thought it was funny. And then the other thing, right, is, and again, if you look at the architecture of this particular car, and I think this maps to pretty much all IoT use cases, is that you have to, as you look at the device, you have to start thinking of what I like to think of as a cocoon of security around the device. So at the beginning of the talk, I think I talked to you about my story about how I started with the Nest, I went to the Protect, and then I was actually looking at the locks, right? And if I could digress for a moment or two here, the story or the thinking about doing the locks was triggered by one very simple use case. I was away for work one day, and then my youngest daughter called me up because she couldn't get into the house. She'd forgotten her key, and no one else was home, and she's figuring out what to do. And I was thinking, hey, you know what? If I could control, the way Leo could control his lights, if I could open the locks remotely, I could just open the door for her, right? So then, my gadget junkie head started spinning, and I started shopping for smart locks. So I went with my elder daughter. She was 15 at the time, and we're shopping, and I'm looking at the different locks, and I'm looking at their aesthetics and their features and the ability to open them remotely from my smartphone and stuff like that. And then my 15-year-old daughter put her hand on my shoulder, and she pulled me and said, Dad, someone's going to hack that. and the funny thing is, she's right. And I don't want to turn this into a session about bashing smart connected locks that they sell at Best Buy, but is it really necessary to open and close your doors remotely? Right? And then I started thinking about my outcome in my particular use case, and I realized I do need a lock that's smarter than the one I have, but quite frankly, a biometric scanning capability on it would have achieved a lot of what I needed and not expose me to these types of things. So again, it's just a consideration, and I think it's really important as we're engineering IoT experiences, we don't just think about the device, think about the outcome and truly what the user is trying to accomplish. In this IoT journey, we see three phases of evolution. So the first one is connecting things that are currently not connected. Plants, for example, not connected. The second phase is what we call intelligent connected devices, right? And while I love the buzz factor around the term Internet of Things, it's somewhat misleading. I do not expect my toaster to talk to the grid, even though that they're both on the internet. And I think what's going to happen over time, our thinking around the Internet of Things is really going to coalesce around subnets of things, things that are allowed to collaborate, things that are allowed or authorized to work with each other, things that are able to share their data. And I think once our thinking gets there, it's going to open up the next phase of evolution, which is autonomous software-defined machines. And this is really exciting. So you can imagine I'm a company that operates a bunch of windmills, and I bring a new windmill or some other internet-enabled device into my environment. Wouldn't it be really cool if that windmill could, or that new device, excuse me, could talk to the other devices in that subnet and ask them, what have you learned? Has there been a hack here recently? What did it look like? How should I defend against it? Right? And this is the type of intelligence that you can start seeing forming as we start focusing on not just the device, but the data coming off the device and the outcomes that we're trying to achieve. So Porter, and again, if you didn't take notes, I really encourage you to read his article. He talks about this third phase, but what can we learn from the second phase? So I put three companies up here, and they're all very different. So Amazon, they've got a run rate of about $89 billion a year. Originally, they started off selling us books, and now they're the biggest online retailer on the planet. Apple, hardware, computer manufacturer, but they've transformed a run rate of 182, almost $183 billion a year, helping us consume digital content in a very interesting way. And Google, 90% of all internet searches go through Google. So all of these companies have three very, very different business models, but they have one thing that's very in common, that's very important. Each and every one of them know an incredible amount of information about you. And just for giggles, those of you who have iPhones, book an appointment with the Apple Genius Bar and just say, hey, I don't think my battery is running as long as it should. Could you take a look and run some diagnostics? You will be shocked about what they know about you and how you use your phone and where you are and what you do. Now, the good news is they're all using this data for good, right? And they're using it from a business perspective. You caught that, thank you, yeah. Yes, they're all using it for good. And from a business perspective, they're all creating what I like to define as sustainable customer relationships by focusing on outcomes and engineering the consumption of an experience. So they're using their platforms to engineer the consumption of an experience for you. Now, what can we learn from that in the context of machines and machine data? So, and again, just drawing some broad generalities for effect, traditional marketing segmentation has been about building a demographic model, right? So what do men between the age of 40 and 45 typically buy? What do they like? What do they watch? Do they like football? And once you get that profile, you sort of charge them on a bell curve, and then based on your business appetite, you target a segment of the curve. That's the demographic model. If you take a look at what Amazon has done particularly well, is they've transitioned to building a psychographic model. So I know Emeka, I know he's a gadget junkie. He'll pretty much click on any gadget you put in front of him. He's got 2 kids, he lives here, his parents live in a different city. He does a lot of online shopping, spends, I don't know, let's say $700 a month online and stuff like that, and he's quite often buying gifts online and sending them. They've got a psychographic model of me that they could use to tailor services that I, unfortunately, buy more often than I should. This could also apply to machine data. So if you take a look at what's happening with typical engineering of maintenance experiences, companies, they design a machine and they look at it and they draw curves and they say, okay, yeah, this particular machine, it could go about 19 months or 20 months before it fails. So if we get customers to buy maintenance contracts that are on the order of 12 months, for the most part, they'll be reasonably happy, right? What will change if we move to a psychographic model of a device? So let's talk about this, first of all, in terms of humans, right? So if you look at me, if I build what we call, so if you look at the demographic model, and I should back up a bit here, the demographic model is really building a model of the many, right? How do many devices sort of, if we look at their statistics, how do they behave? The psychographic model is really building the model of one, right? So in the case of humans, the model one is simple. like your age, your relationships, your spending behavior, your purchase history. Once they get that data, they could basically tailor profiled and optimized services for you as a personal P&L center. And then finally, they could leverage that information in order to offer you customized value-added services. That's what happens in the case of humans. Does this translate to devices? I think it does, right? You could get insights about a specific device, a motor. Is it operating in a clean environment? Is it operating in a dusty environment? Has this particular engine been driving, like flying in smooth air, or has it been subjected to a lot of turbulence? The elevator, are we seeing that more people are using the elevators that are close to the reception versus the ones that are at the end of the line? And then once you start getting that information, you can start figuring, it's like, okay, well, when does this specific unit, right, not this family of units, when does this specific unit need to be maintained? When does it need to be decommissioned, right? Or you could create new business opportunities. So for example, customized maintenance contracts, maybe buyback plans, right? You could see a particular device as it gets closer to the end of its utility might not have the same value to the owner of that device, but might have tremendous value to someone else in the economy. Guaranteed resale value, add-on products. You could tailor replacement products. There's so much potential if you move from the model of many to the model of one for what you could do with IoT once you focus on business outcomes. So a little bit about us. So Wind River, we've been in this business for 30 years. In a nutshell, our business is really helping customers build things that can't fail. And we think that's really important as we transition to IoT. In 2009, Intel acquired us. For many years, we wondered why, but I think we see it now. Intel sees a huge opportunity around the numbers of devices that Intel could start taking its low-powered chips into to enable IoT, and Wind River could be the software vehicle to enable that value and unlock that value. We've been serving some of the biggest brands in the world across several of the spaces or non-consumer spaces, so A&D, automotive, network infrastructure. I should have said it earlier, we were in no way involved in that Chrysler debacle. That wasn't us. Our core values from an IoT perspective are ease of use, end-to-end security, high availability, robustness, predictable real-time performance. And this is something where we're very passionate about. So the traditional internet is built on 3 nines reliability. We realize that things in the cloud could go down, and it's okay. But as you start to take a look at healthcare or transportation, smart cities, autonomous driving, we strongly believe that you need a much higher level of reliability than the existing infrastructure provides. And then extensibility, right? The device that you deploy or commission right now will not be the device that's generating or not be generating the same value that it's going to be generating 2 years from now. We've got a rich portfolio of solutions. I'm not selling product here today. All I'm going to show you is that we have a rich portfolio of solutions. And as part of Intel, can I show you a movie? All right. So I'd like to share with you Intel's broader point of view for how IoT could help make life better.
Imagine if Intel changed your vision of the world. You'd be able to monitor natural resources, spot ways to increase crop yields, and focus on building and sustaining a better, safer future. Your space would have a sense of intuition. The door would know when you left the office, and your car would see you coming. You would intuitively know how to avoid traffic. Work would be less of a routine. Your perception at work would make you Employee of the Month. Your home would recognize whether it was you or the mailman. Your pool would sense if a loved one was in too deep. And together, you would embrace the unexpected. Now the ordinary has become extraordinary. Intel Inside makes for a better experience outside.
I like that. And just gives you a taste of the types of outcomes that IoT can enable. So, just in conclusion, the future is now. And I encourage you, as you're thinking of your IoT ideas, focus on the outcome. Focus on engineering reliable, trusted experiences. and then finally embrace the model of one and explore the model of one. Thank you very much.